In section 31, this is really accumulation of a lot of problems throughout the year. So there are quite a few problems that are pretty difficult. So I'm going to take a look at, let's say, problem number 2. All right, so in problem number 2, this is one style of the types of problems we have. This style is fraction equals fraction. All right, so fraction, there's no plus or minus signs in between the fractions. One fraction equals one fraction. When you have that, the best thing to do is to cross multiply. Don't worry about a common denominator, don't worry about anything. Just multiply along each diagonal. It doesn't matter which diagonal you go first. So I'm going to take x times x minus 3, then I'm going to go the other direction. And I'm going to do equals 1 times 9 minus 3x. Now we don't need the 1. I'm just trying to go through it step by step. Then of course, no more fractions, so we don't care about anything but multiplying, combining like terms. So we get x squared minus 3x, and on this side we have 9 minus 3x. Then all you have to do is try to combine the letters and numbers and everything that you can do. So I'm going to add 3x to both sides. And when you do that, that's actually gone. So we get x squared equals 9. When you take the square root, you get two answers, 3 and negative 3. And I wrote it out separately, not plus or minus, because I want to consider each answer. So if you plug a positive 3 back into the problem, so we'd have 1 over 3 minus 3, and right there you can kind of stop because 3 minus 3 is 0. You're not allowed to have a 0 in the bottom, so positive 3 doesn't work. If you put in a negative 3, we get 1 over negative 3 minus 3, and this is a negative 3, and then this is 9 plus 9. So we don't have 0 in the bottom of anything. We really don't care about anything else as long as there's no zeros in the bottom, and so this one actually works. So that's one style of problem, cross multiplying. Another style of problem is really the rest of them. Some of the problems at the end are actually easier. Like number 5 is a pretty simple problem. I'm going to take a look at number 3. So that was number 2. Let's take a look at number 3. In number 3, we have 3 fractions, meaning we can't cross multiply. So when you have more than 2 fractions, you have to multiply by the common denominator. So in this style, we're going to multiply by the least common denominator. The best way to find the least common denominator is just to multiply all the denominators together. So the denominator is x times x minus 1. That is the common denominator. So when we do that, you put that in the top. X times x minus 1. X times x minus 1. I put it on each one. And then you treat each fraction like its own problem. So that's gone. So what we have left is x times x. Then the equal sign. X minus 1s are gone. So we have x times 1. And then here just the plain x is gone. So we're left with plus 2 times x minus 1. So we get x squared equals x, and then distribute. Plus 2x minus 2. Well, we have an x squared, so I'm going to try to get everything on one side so that I can factor it. So I'm going to bring this over here and bring this over here. So I'm going to have x squared minus 3x plus 2 equals 0. Well, this has to be factored. So we need two numbers. When you multiply, you get 2, and when you add, you get 3. So the answers are the opposites, as you know. We get x equals 1 and x equals 2. Well, you have to go back and check the denominator. You have to check the denominator. So if you put the 1 in here, and I know I crossed it off pretty good, it was x minus 1. We would get 1 minus 1. We get a 0 right away. This is gone. If you check the 2 works. 2 minus 1. 2. So the 2 will work, and all the rest of them, it just, the 1 does not work. And we had another kind of style. It looks a little bit different. Like problem number 6. Problem number 5 really is one of the easiest ones, but problem number 6 is a little bit different. I don't know why this doesn't, oh, there we go. So problem number 6. 3 over x plus 1 plus 2 over x minus 4. And then this denominator, we don't know what it is, right? You got to factor this in order to see its parts. So if you factor that out, multiply to get 4, and then subtract to get a 3. So we want it to be -4, -3 rather, so -4 of 1. So we want to use all the different factors. So I need to use x minus 4, and x plus 1. Perfect. That's all we have anyway. So it looks like it's going to work out pretty good. So I'm going to multiply by x plus 1 times x minus 4, all 3 fractions. In this fraction, the x plus 1 is gone, so we're left with 3 times x minus 4. Then we have plus 2, x minus 4s are gone, x plus 1. And what happens over here is all of this is gone, and you're left with 4x minus 11. Do some distributive property. Combine like terms, so 3x and 2x, that's 5x. -12 plus 2 is -10. We don't have x squared, so we're not going to have to factor. So subtract 4x. And then add 10. So we get x equals -1. You have to check that. If you go back and plug the -1 right here, -1 plus 1, that is a 0. So this doesn't work. It is our only answer, so that means we have no solution. You could also do a circle with a line through it if you prefer to do it that way. I'm going to show you one more. The last one. This one is a lot like number 5. Number 5 is a lot easier though. Now this 3 is really 3 over 1. Remember, we want the denominators. So your least common denominator is just the 2 denominators multiplied together. The 1 doesn't count because it's not doing anything. So our common denominator is x times x plus 1. So here the x's are gone, x plus 1's are gone. And this is what makes this hard, is that none of this is gone. So that just makes it more stuff. So we have 2 times x plus 1 minus 4 times x equals 3x times x plus 1. Distributive property, and we have x squared. So I'm going to combine like terms here. So we have 2 minus 2x. And I'm going to move everything towards the 3x squared. So I'm going to add the 2x and subtract the 2. So we get 3x squared plus 5x minus 2. And on top of that, it's not an easy one to factor. So this, like I said, there's a lot of complicated parts here. So I'm trying to get to 2, which means I can only use 2 times 1. And I want to get a 5 in the middle. So outside is a 6. Inside is an x. So I want it to be 6 minus 1. So 6 minus 1. So 3x minus 1 equals 0. So we get x equals 1/3. And x plus 2 equals 0. So we get x equals -2. Now you can do this a different way if you'd like. You already know, if you take a look at your denominators, that x cannot equal 0 and x cannot equal -1. So the reason we spend so much time saying the exceptions is that's supposed to make this step easier now. So if you don't get a 0 or a -1, you're good, and we didn't. So that means both of these answers work. I hope that helps with some of this stuff. I know, like I said, this is Some of these problems are difficult because it's just a lot of algebra all built into one problem. But you can do it.